Question 16 wants us to find the equation of the slant asymptote, or sometimes called oblique asymptote, for the following rational function. Okay, so it is helpful to know, it's a little bit of rule memorization at first here, but you need to know when a rational function is going to have a slant asymptote in case there was a choice of none. And it's only going to have a slant asymptote when the degree of the numerator is 1 bigger than the degree of the denominator. So this one does in fact have a slant asymptote. The way you find the equation of the slant asymptote is you have to do long division. So we need to divide this into this. Okay, so the process of long division says this times this needs to give me this. So I know I need an x, because x times x to the third is x to the fourth. And then I have to think about what number times 2 gives me 3. So that is going to be 3 halves. 3 halves times 2 just gives you 3. Since I knew I was timesing by 2 here and I wanted to get rid of it, I wanted to divide by 2. And since I wanted a 3, I put a 3. So that's how I knew that. Now, it doesn't just go to this, you really multiply it to the whole thing. So I also have to multiply it to this. So this would be negative 21 half x's. And the preferred way for me to do this is you're really subtracting these. So I ask my students to instead change the signs and add them, just because there seems to be less arithmetic mistakes there. And these two should go to 0. And all 3 of these are in different terms, so none of those combine. X squared, 21 halves x, and a minus 7. Now with this long division, the equation of the slant asymptote is going to end up being y equals the quotient up here. The remainder is going to have no bearing on the slant asymptote. So this is looking kind of messy, but I don't think I'm going to have to go far enough for that. So most of the time with long division, you need to go more than once. So repeat the steps. This times this needs to give me that. And unless I start dividing by x's, that's not going to work anyway. So all of this ends up being the remainder. It's kind of messy, but again, the remainder has no bearing on the slant asymptote. So my answer should be y equals 3 halves x. Look at our choices, and that would be choice A. Now the other thing you can do, you can graph this, and if you know what a slant asymptote looks like, you might be able to get the answer from the graph. So let's go ahead and look at that for just a moment. When you graph this, make sure you put parentheses around the numerator and parentheses around the denominator. If you don't, your calculator is going to do the order of operations different than what you intend. Okay, so here's the rational function graphed, and an asymptote is like a break in the graph. A slant asymptote is one that's at a slant. So like this is a vertical asymptote. That's why it spikes. The graph spikes right here. It goes down to negative infinity and up to positive infinity on one side or the other. So a slant asymptote is the same idea, but instead of being vertical, it's at a slant. So I can see it right here, where it's close to this and close to this, the ends of the graph. So the answer is the one that's supposed to fit right in there. So I guess I could have graphed all 3 of these, or all 4 of these choices, and see which one of those equations fits right in there. Actually, I guess with these, having these y-intercepts, they're going to be down here somewhere. So that might have been faster, but I've already done the work, I've already done the long division, so I'm going to go ahead and graph it at the same time, and then you can see it fits right in there just perfectly. So now I am confident number 16 is correct.